Today's lesson is called More on Basics of Functions and Their Graphs. The first thing we're going to be talking about is piecewise functions. So let's talk about what a piecewise function is. A piecewise function is a function that is defined by more than one equation of a specified domain. Okay, that's a whole lot of words for saying sometimes you're going to use one function and sometimes you're going to use another. So first I want to just give you like a real-world example where let's say you're getting a cell phone plan and you're going to pay $25 for the first 10 gigabytes of data. Okay, so let's just say we're talking a data-only plan. So you're going to pay $25 for the first 10 gigabytes of data, but then every additional one that you went over your 10, because you're going to estimate you're going to probably under 10 and you're just going to pay 25 bucks a month. But if you go to 11 or 12 or 13 or 25, every additional gigabyte after that is going to cost you another $7. So you have two different equations here. The first equation is what you're going to pay from 0 to 10 gigabytes. No matter if you don't use the phone at all or you use all 10 gigabytes for that month, then you're going to pay $25. That's one rule. Every rule needs to have its own equation over a specified domain. But anything over 10, you have a different rule. You're still going to pay the $25, but then in addition, you're going to pay some more money. So we're going to have two different functions describing the plan depending on, how much data you use. So we have c of x equals, and then it has this large bracket. So on one of the equations, the answer is just going to be $25. $25 as long as you stay within 10 gigabytes of data. So that would be as long as, or if, okay, we can write if x is less than 10. Truly less than or equal to, because if you do 10 gigabytes exactly, then that's what you're going to pay. Now anything over 10, you're going to have to pay $7 per gigabyte for that one. Now, there's probably a lower bound here. You can't have anything less than 0, so my domain is anything from 0 gigabytes to 10 gigabytes. So the next domain would be if x is greater than 10. Anything greater than 10, you're not just going to pay the 25, you're going to pay 25 plus something else. So that is defined by another rule. 25 plus an additional $7 for every gigabyte over 10. The way we do that is going to be x minus 10 in the parentheses. So let's say you have 11. 11 minus 10, that's 1 extra gigabyte. 1 times 7 is 7. And 7 plus your original 25. Okay, so the x minus 10 means anything over 10 gets counted. So this is our rule. Now I know I'm not really expecting you to be able to come up with that on your own, but I just wanted to give you an example of, well, sometimes you're going to pay one thing and sometimes you're going to pay another depending on the gigabytes. And this happens, a lot in the real world, where there's one rule applies if these conditions are met, but a different rule applies if these other conditions are met. So it gets a little bit confusing. So you just need to have piecewise functions in order to handle those situations where there might be conditions. Okay. So let's say we're trying to find c of 4. This 4 right here means x, or the amount of gigabytes. So we're looking, does 4 belong in anything between 0 and 10, or does it belong anything greater than 10? Well, in this case, 4 is somewhere between 10 and 0. So because 4 is between 10 and 0, then the first rule applies. So the cost would be 25. If you have 4 gigabytes of data, you're going to pay $25. Why? Because you plug that into the first function of your piecewise function. So what if you're trying to find c of 15? Well, in this case, because 15 is greater than 10, you're going to have to use the second rule. And the second rule says 25 plus 7 times x, which is in this case is 15, 15 minus 10. So we have 15 plus 7 times 15 minus 10 in parentheses, you subtract. So that's an extra 5 gigabytes over what you had anticipated to pay. So it's 25 plus another 35. Woo! So that gets you, let's see, 60. So therefore, C of 15 is 60. So thinking about this, $7 per 1 gigabyte is not so good, especially if you can get 10 for 25. So this is probably not the best plan, depending on how much data you use. But nonetheless, that is how you use piecewise functions. Okay, to find a piecewise value with a piecewise defined functions, you must look for the domain in which the value belongs in. Okay. Then you need to substitute that value into the corresponding function, which we kind of showed you, but let's do a couple more examples here. So we have a new function. Let f of x equal the piecewise function 6x minus 1 if x is less than 0, or 7x plus 3 if x is greater than or equal to 0. All right, notice that 0 is only equal in one of them. The first domain, it goes right up to 0, but in the second domain, it includes 0 and then goes past it, okay? So this is a function. 0 is not defined in two places. If remember when we've talked about functions, 0 can't be dating, any x can't be dating more than one y. Well, 0 is only dating one y because it's only a domain of the second function, not the first, just to be clear there, okay? So when I'm doing f of negative 3, is negative 3, does that belong in the first function? Is negative 3 less than 0? Or is negative 3 greater than or equal to 0? Well, it looks like it's the first domain. So I'm looking at the domain first. Once I figure out which domain it belongs in, then I find the function. The function says 6x minus 1. So I have 6 times negative 3 minus 1, which is negative 18 minus 1, or negative 19. Sometimes students will try to plug negative 3 into both parts and just hope that I pick the right one, and that I'm not going to do that, okay? If I see more than one answer, I know you don't know what you're doing, and I'm going to count it wrong. Okay, I'm going to erase that part right there. The next one, f of 0. This is a tricky one. Does 0 less than 0 or is 0 greater than or equal to 0? It has to be the second one, and the second one is true because of the or equal. 0 isn't greater than 0, but 0 is greater than or equal to 0. So therefore, I'm plugging it into the second function, which is 7 times x plus 3. But my x is 0, so that's 0 plus 3. Okay, so notice I'm doing the domain first. And the third one, 4. Does 4 belong in the first domain? Is 4 less than 0? Or does 4 belong in the second domain? 4 is greater than or equal to 0. Which one of those is true? Well, 4 has to be greater than or equal to 0, so that means I'm plugging it into the second function. So that's 7 times 4 plus 3, which is 28 plus 3, or 31. Let's do this one more time. New function g of x is equal to x squared minus 5 if x is not equal to 0, or 4 if x is equal to 0. So this x is not equal to 0, if you want to think about it like it's x is less than 0 or x is greater than 0. Anything below 0 will work, anything above 0 will work, just not 0. If it's equal to 0, then it's a different function, okay? So as the first one, is negative 2 equal to 0 or not equal to 0? Well, it's not 0, so I'm going to go ahead and plug into the first one, which is negative 2 squared minus 5. Negative 2 squared is positive 4, and 4 minus 5 is negative 1. On the next one, g of 0, is 0 equal to 0 or is 0 not equal to 0? Well, it is. So this one's really easy. There's no plugging in to be had at all. If x is equal to 0, then f of x equals 4, period. Easy. No work to be shown there. And then the last one, we have g of 4. Is 4 equal to 0 or not equal to 0? Well, 4 isn't 0, so I'm going to go ahead and plug it into the first function. 4 squared minus 5, which is 16 minus 5, or 11. And that's it.